so the general form of a conic equation. You've seen this, but in general, you've seen this on your paper with different numbers and stuff. You haven't seen it in this general form exactly like this. And don't ask me why we skipped the b, but we do for some reason. Ax squared plus cy squared plus dx plus ey plus f is equal to 0. Now, any number of those could be a 0. Okay, not all of our conic, like parabolas. It only had either x squared or y squared. They didn't have both of them. So either a or c would be 0 in that case. We've had some that haven't had the x or the y, so those could be 0 or may not have a constant. But that's just the general form that covers them all. So here's the good news. If you're looking at a general form, you should be able to identify what type it is because they all have something unique. So the first question we ask ourselves is which variables are squared? If there's only one of them that's squared, either x is squared or y is squared, what is it? It's a parabola. It's a parabola. So that's stop number 1. Thought number 1, question number 1. Which variables are squared? Only one of them is squared, it's a parabola. If both of them are squared, then we want to look at our coefficients on those squared terms. If they are exactly the same, it's a circle. If they are different, but they have the same sign, it's an ellipse. If they have opposite signs, it's a hyperbola. Okay, so first question is which one's squared? If only one of them squared, it's a parabola. Next question, look at the signs. I look first of all for opposite signs. I think it's easier to eliminate or determine whether it's a hyperbola than if they have the same signs, then it's a circle if they're the same coefficients, it's an ellipse if they're different coefficients. So let's look at these 4 right here, and we should be able to identify them very quickly and easily. Looking at number 1, we have x squared and y squared, so it's not a parabola. They have the same sign, so it's not a hyperbola. They have different coefficients, so it's an ellipse. Number 2 only has x squared. It's a parabola. Number 3, both of them are squared, not a parabola, same signs, not a hyperbola. They have the same coefficients, so it's a circle. The last one, both are squared, not a parabola. They have opposite signs, so it's a hyperbola. Now, looking at it, we would say since the x squared is the negative, then it should be opening, up and down. If the y is positive, that comes first. But you never know. Sometimes what you end up having to divide by in the end throws that off. So until you truly put it in standard form, you can't really identify that yet. All right. I don't want to spend a ton of time on these. I really just want to do a couple of them when it's in standard form and going to the graph, just because you've been practicing this along the way. So let's look at these. First of all, let's just identify what they are. Let's get a little bit more practice with identifying what they are. Number 5, which one is it? Parabola, because only one of them is squared. Number 6, what is it? Hyperbola. A hyperbola, because both of them are squared, but they have opposite signs. Flip your paper over real quick. Number 7, which one is that? Circle. How about number 8? Ellipse. Okay, it's an ellipse because they're both squared. They have the same signs, but they have opposite coefficients. I'm not currently looking at number 9 and 10, but y'all tell me what they should be. Number 9 is a parabola. Okay, only one of them is squared. How about number 10? Circle. They have the same signs and the same coefficients. Okay, so it's a circle. Y'all tell me, which one would you like to review? Parabola, ellipse, or hyperbola? Hyperbola. Okay, let's look at a hyperbola. I had a feeling that would be your answer. Let's do number 6 then. Okay, we're going to graph it from the standard form, so that means we have to go through the process of completing the square. So put your x's together, leave yourself a space. That's a minus. Move the constant of 9 to the other side. Complete the square with the x's. 4 divided by 2 is 2. 2 squared is 4, so add it there, add it to the other side. Here's one thing that we need to do with our y's before we complete the square. That negative is like having a 2 or something in front of it. You have to factor that out, so that's going to change that to a positive 6y. Factor out the negative from the y squared and the negative 6y, so that becomes y squared plus 6y. Now complete the square. 6 divided by 2 is 3. 3 squared is 9. We had a GCF in front. It's a negative, but we still have to include it, so that makes it minus 9 on the other side. 9 times negative 1 is negative 9, so we add negative 9 to the right side. So our factoring, x minus 2 squared minus y plus 3 squared is equal to positive 4. It's got to be equal to 1, so we go through and divide everything by 4. So we have x minus 2 squared over 4 minus y plus 3 squared over 4 is equal to 1. So our center, the x-coordinate is positive 2, the y-coordinate is negative 3. Go ahead and plot that to negative 3. In this case, our a squared and b squared are the same value. So a is 2, b is 2. So we're going to go 2 in all directions. Because the x squared is first, that means our vertices are to the left and to the right. Draw your little box, or you don't have to draw a box. You can just put your asymptotes. They have a slope of 1 and negative 1 in there. Go through the center, slope of 1 and negative 1. Remember, it goes through the corners of the boxes. Okay, and then the sides of our hyperbola just follow the asymptotes. Our foci technically are a part of the graph, so let's just talk about that real quick. C squared is equal to a squared plus b squared for the hyperbola. So that is c squared is equal to 8, so c is equal to the square root of 8, which is between 2 and 3. So our foci are really close to our vertices there. Hopefully you can see those little green dots. They're just not even one more unit out from the vertices. Okay. One more little thing that we got to talk about. This is not in your notes page. Okay, this is not in your notes page there, but it doesn't take up much room. So if you want to stick it somewhere on that packet, I don't have any white pages on there, or if you just want to do it on a separate sheet of paper. Before Christmas, we talked about the polar system and how we can graph things in the rectangular system. We can graph it in the polar system. Sometimes it's easier to graph it in the rectangular system. Sometimes it's easier to graph it in the polar system. And sometimes it's easier to put it in our calculator one way or another. If you know how to do these by hand, graphing them in the rectangular system is not that bad. But if you were trying to put this in your calculator, to get your calculator to graph it, it would take a lot more work to graph these conic sections in your calculator. But if they give it to you in polar form, it's actually not that bad in polar form. So the general form of polar equations of conics, you'll have a constant on top over another constant plus a constant times cosine of theta. It could also be sine of theta. It doesn't change the conic section, it just changes the orientation. Cosine's on the x-axis, sine is on the y-axis, okay? That whole concept has not changed. So here's how you decide which one it is. Because they all have the same form here, but here's how you decide which one it is. You take the constant that's being multiplied by the trig function and you divide it by the constant that's being added. So over here I have that E is equal to C divided by B. E is equal to C divided by B. If E is greater than 1, it's a hyperbola. Think about the term in English, hyperbole. What is hyperbole in English? Extreme exaggeration. Your English teachers have done a good job there. It's extreme exaggeration. So greater than 1, extreme, connect those two. Okay, so if it's greater than 1, it's the hyperbola. If it's equal to 1, it's a parabola. If it's less than 1, it's an ellipse. I'm going to be honest, I haven't really come up with a good way to remember the parabola versus the ellipse. Other than the parabola has like one curve, the ellipse is kind of like two curves put together. I don't know if that helps or not, but... Oh, actually I did. Less than, ellipse, the L's in ellipse go with less than. That's what it was. I knew I had something else. Couldn't remember what it was. If E is less than 1, ellipse, the L's, put them together, okay? Less than, ellipse. Like I said, cosine could also be sine. That just changes your orientation. Cosine would be horizontal, and sine would be vertical. So it all just comes down to, and I have seen a question, there is a question like this on the released part of the exam that they've given us, that they just give you a polar equation and they ask you which conic section it is. And you've got circle, hyperbola, parabola, and ellipse. Now, I don't have circle on the list. The reason why I don't have circle on the list is because think about the equation of a circle in polar form. We did those. Typically, they were just R is equal to some constant. So like R was equal to 5, that's a circle. Now, sometimes they weren't centered on the origin, so they had something else attached to them, but that was pretty much it. Okay, circle doesn't look like these. The circle doesn't have the fraction. Okay, circle doesn't have a fraction. In polar form. All right. So I've got a couple of examples here. I want y'all to go through the list and just do the C over B, determine what E is. Is it greater than 1? It's a hyperbola. Is it equal to 1? It's a parabola. Is it less than 1? It's an ellipse. And identify these, and then I'll show you really quickly in the calculator why you need to know that value of E. Okay, so you can write it down here in a second. Y'all just tell me here by visual inspection. Example A, 3 over 4 plus the sine of theta. If there's nothing in front of the sine, that's a 1, right? So E is 1 over 4 here. So which one is that? Ellipse. It's less than 1. 1/4 is less than 1, so this one's an ellipse. B, E would be negative 7 over 2. Ignore the negative, okay? You just consider the absolute value of this. So 7 over 2, what would that make it? Hyperbola. Okay, how about C? E is 4 over 4, so that's equal to 1. So that one's a parabola. And then that last one, I already used R equals 5 as an example, but that would be your circle. Now, if you recall, I showed you how you can graph things in polar mode, right? Change your mode to polar. Go to your y equals. Now it says R equals. Let me try and do the hyperbola here. 35 over parentheses 2 minus 7 sine theta. Okay, let's see here. Let me check my window. I'm in radian mode. All right, so when I hit graph, this one actually graphed it pretty good. Clearly, you could see, if you know what they're supposed to look like, you can tell that this is a hyperbola. But the one on the release test, unless I'm just doing something completely wrong when I type it into my calculator, it doesn't graph the entire thing. It's not very obvious that it's a hyperbola. But look, I mean, it's really easy just to type these in, and it graphs it. Whoops, I forgot the divided by. It graphs it very easily. And like I was saying, if you tried to graph these in rectangular mode using your calculator, it wouldn't turn out so well. We would have to zoom in to see this one a little bit better because it's really tight in there. But obviously you can see that is an ellipse. I can do the parabola just as easily. But like I said, the one on the test, for whatever reason, you would have to be able to play with your window and mess with those numbers to be able to get it to graph just right for you to be able to tell that it's a hyperbola. So it's just easier if you remember this E thing.